If you think you know what the universe is like, it seems like you're about to get an entirely new angle on what the universe is like. There are entirely too many questions when we think about what is in the vastness of the universe. But what if we tell you we have an answer for that? A spellbinding one. So let's take a look at the deepest ever image of the universe that has been making rounds on the internet. Let's begin. Recently, NASA has released what is being termed the first full-color image sourced from the James Webb Space Telescope. The image was officially distributed by NASA and President Joe Biden, and currently, this is the deepest we've ever peeked into the cosmos. Named Webb's first deep field, the fantastic image shows our universe merely a couple hundred million years after the Big Bang occurred, just as galaxies began to consolidate and light started to be emitted from some of the earliest active stars. This starlight took nearly 13.5 billion years to reach us, which, by the way, is almost as long as the universe has been in existence, arriving at the James Webb Space Telescope, also known as JWST. This took place after the space-time bending gravitational pull of the galaxy SMACS 0723 steered even the faintest specks of light into focus. Bill Nelson, who serves as the chief administrator at NASA, explained what we have to gauge from the image, saying, "We're going back 13.5 billion years, and since we know the universe is 13.8 billion years old, we're going back almost to the beginning," which, if you think about it, is insane. This single image could help us know what was at the beginning of the universe, even before the Big Bang. This means that logically, these extraordinary views of the cosmos can allow astronomers to find answers to the questions we haven't even asked as of yet. The image in question is a remarkable one that gives a super HD view of these overwhelming, dense, prolific amounts of galaxies, stars, and planets contained within the exponentially expanding universe. And despite all of this is still objectively one of the tiniest glimpses into the universe. Are you guys as curiously baffled as we are? Moving on, Nelson explained how if you hold a solitary grain of sand on your fingertip at arm's length scientifically, that is how much of the universe you're going to get to see in that image. Just one little grain-sized speck of dust. He went on to speak about how the spectrum of theoretical physics and astronomy has expanded almost as exponentially as the universe, explaining how nearly just 100 years ago, which is very, very recent history, humans thought that just one galaxy existed in the vastness of space. Now that number has quadrupled to infinity. So, in just our galaxy, we have billions of stars, moons, and suns. And consequently, there are billions of galaxies with billions of stars, moons, and suns. Yes, so technically, the known universe is only as wide as infinity. Human imagination can't even be compared. If you've been surfing the internet, you've probably seen two comparison images side by side, one which is taken by the James Webb Telescope and the other which is taken by the Hubble Space Telescope. To be fair, even if the JWST took the better, more aesthetically pleasing image of the universe, the Hubble telescope still holds the distinction of taking the deepest ever glimpse into the universe first. The series of images it took displayed how several hundred million years after the Big Bang, galaxies had already started to coalesce in our very adolescent universe. But if we might have ventured to go even further back in time, scientists needed to construct a telescope that is sizable enough to capture light from the faintest sources and is also capable of catching the mid-infrared frequencies of the most distant light, which had been shifted by the universe's expansion. This is where the James Webb Space Telescope came in. Its rudimentary mirror diameter amounts to 21.6 feet, 6.6 meters wide. If we compare it against Hubble's mirror, which is just 7.9 feet, 2.4 meters wide in diameter, this is significantly bigger. This tells us that the JWST can detect objects that are 100 times less luminous than Hubble could see, meaning it has a way lower aperture and stronger light sensitivity. The telescope is also capable of scanning the entire universe in infrared, which enables it to find and locate galaxies that came into existence merely 200 million years after the Big Bang occurred. The JWST's subliminal sensitivity to detect infrared frequencies means that it needs to be isolated from heat signals on Earth that might disrupt the reception of those other targeted frequencies. Therefore, as of now, it currently is located in a gravitationally balanced periphery that lies beyond the moon's orbit. This is known as Lagrange Point, after being launched there from French Guiana, mounted on an Ariane 5 rocket on Christmas Eve 2021. After the 6 months that it was launched, NASA engineers carefully calibrated and tuned the telescope's intricate mechanisms and mirror segments in plans to snap the first ever images of the universe taken by this telescope. However, like all things in life, the road to this miraculous discovery isn't very smooth. Their procedure was interrupted, albeit briefly, after the telescope was struck, unexpectedly, by a micrometeoroid, somewhere between May 23rd and May 25th. But thankfully, the collision did not damage the spacecraft. NASA is set to release 4 more images, offering views of the interstellar platform, the atmosphere of the fantastical exoplanet, and exquisitely figure 8-shaped gas trace from a deceased star, and a quintet of galaxies located in a cosmic dance of endless near collisions, according to statements made by NASA. Watch this space for more coverage on the upcoming cosmic images. And because light travels at 186,000 miles per second, meaning that the light observed in a solitary, isolated speck within the image has been commuting for more than 13 billion years. Now that's a long journey, isn't it? And coming back to what we said earlier, he might have possibly have confirmed that future images will be able to capture a space-time dimension that goes even farther back into the ancient universe, way farther than 13.5 billion years ago, almost to when there was nothing, and when there was finally light, the beginning. Webb's other properties will help cosmologists research the chemical proponents of the atmosphere of planets outside our solar system and whether they carry the potential to be habitable. Vice President Kamala Harris, who heads the National Space Council, said that the Webb telescope, the biggest and perhaps the most uniquely formidable tool of its kind, will enhance what we know about the origins of our universe, our solar system, and possibly life itself. Isn't that a prospect that excites you guys? While Harris posed deeply metaphysical questions at the discovery of this image, President Biden called the telescope a new window into the history of the universe. And as much as a matter of national pride as it may be for the government of the United States, they can't possibly praise the people actually at work for the past 30 years enough. The James Webb Telescope took nearly 3 decades to design, build, and finally launch. The telescope is blueprinted to observe some of the most primordial artifacts in the universe, as well as many that are relatively newer and near Earth. However, both telescopes have been equally important in our study of the universe. Webb, a successor to the historic Hubble telescope that flipped our perception of the cosmos, can be considered a modern, real-life time machine, said John Mather, a senior scientist at NASA. That's because Webb is actually inheriting the light first radiated by a multiplicity of celestial objects, and not as they come to be today, but how they were nearly 13 billion years ago. If you look at things really far away, then you're looking pretty far back in time. So it starts to add up, Mather added. The Webb telescope is a collaborative endeavor between the Canadian Space Agency, CSA, and the European Space Agency, ESA, but it is of course spearheaded by NASA. It picks up on incredibly faint, ancient light that is still traveling from distant objects across our expanding universe. Over the time that it's been in commission, the original wavelengths have changed and warped from ultraviolet light, visible light, to infrared light, invisible light, in a process called cosmological redshift. Interestingly, before its release, NASA posted an image it had clicked during an engineering exam of the telescope's capacity to focus on a faint target, the plethora of stars and galaxies, which appears as amber punctuated with light flares, is another testament to what we can hope to expect from the glorious Webb telescope as it kicks off its plan to get the most ancient, archival footage of the universe it can, and man are we excited. And that's it for all about the history of the cosmos for now, folks. Join us as we voyage through the past, present, and future of our known universe. But until the next video comes out, make sure to check out other space-related content. Until then, ciao!